So in this video, I will do a chapter test on 32 questions of basic geometry problems. Problems include true or false using figure, use a segmentation to answer the questions, find the indicated angle, find an angle measure, find the midpoint and distance of a given segment, find the values of the variables, find the values of the variables and make a conjecture, and finally find the perimeter and area of each figure. So for questions 1 through 6, use the figure to answer the true or false questions. So let's say you have two planes. The yellow is the one plane and the orange is another plane. And you have some kind of line that bisects the two planes, right? So question 1 says, is point P on plane? So where's point P? Yes, point P is on the orange plane, right? It's actually in both orange and yellow. So I'm going to say true. And the reason is since point P is on both orange and yellow piece of paper. Okay, number 2, point X is on line segment AB. So where is point X on the plan? No, right? Here's X. It's on the yellow. Is it on anywhere on the line segment AB? I mean, ray AB? No. It's, ray AB is right here. Point X is right there, so it's going to be false. Okay, number 3, plane M intersects plane R in ray AB. So plane M, where is plane M? Oh, it should be right here. This should be M. So the yellow piece of paper is plane M. So does plane M intersects plane R? Yes, plane R is the orange one. So the yellow is plane M, the orange is plane R. Do they intersect? Yes. So does plane M intersects plane R in line segment AB? I mean ray AB? Yes. Yes, it does. Ray AB intersects both planes. I'm going to say true. Okay, number 4. Points B, P, and X are collinear. So what is collinear? They have to be in the same line. Can't be kind of spread out. So is that true? So let's look at point B, P, and X. X is right here. They're not collinear. They're not on the same line. So it's going to be false. Number 5, point A, B, and X are coplanar. So what does coplanar mean? It just means are they in the same plane? It doesn't mean they have to be in the same line on like linear. It just means are they in the same plane? So let's see. So it's point A, B, and X. Here's where they A, B, and X. Yes, they are in. I'm going to say yes. A, B, and X are in the same yellow piece of paper, plane M, right? So I'm going to say true. Okay. Number 6, line L and ray AB are coplanar. So are they on, so what does coplanar mean? Are they in the same plane? So line L, so let's look at our figure. So does line L, here's line L, and ray AB um, are in the same plane or coplanar? Yes, they're both on the orange yellow piece of paper. I mean, yeah, the orange. They're both on the orange piece of paper. So yes, true. Okay, let's do for number 7 through 11, use the diagram to answer the questions. Here we have like some kind of cube. I try to make my best cube. It's supposed to be a cube. So for yeah, use the diagram to answer the question. So name 3 collinear points. So what is collinear? It means it just has to be in the same line. It's not the same thing as coplanar, meaning coplanar is has to be in the same plane, but they all okay. So there's more than one answer. Name 3 collinear points. So one would be points QTN. Right here is QTN. That's in one example. What's another? NXU. And I think that'll be it because they want three, exactly three, right? So it's just going to be NXU or QTN. Okay, number 8 says name for a non-coplanar. So what is non-coplanar means not on the same plane. Not. Okay, so let's look at our figure. Name 4 non-coplanar points not in the same plane. So maybe L, P, M, where's M? And R. Yeah, so maybe LPMR because here's L, here's P. L is on this plane, right? P is on this plane. And then M is on this plane. And then R is above here, right? There's like there's several more, yeah. So they're all in the different planes. So maybe yeah. And then maybe also L, S, P, and N, right? L is on this plane, S is on this plane right here, and P is on this plane, and N is on this plane right here, right? So yeah, it could be LPMR and LSPN. Okay. Number 9 says name 2 opposite rays. So let's look at our figure. What are 2 opposite rays? So maybe ray TQ, they're like in the opposite direction. Also maybe TN or even XU and also maybe XN. Yeah, sorry, U is should be right here. Okay, so 2 opposite rays would be ray TQ and then ray TN, also ray XU and ray XN. Okay. Number 10 says name two intersecting lines. So answer may vary. So two intersect name two intersecting lines. So maybe ray QL and QN. There's probably more others like yeah, but one of them yeah would be ray QL and QN. Number 11 says name the intersection of plane LMN and plane QLF. So name the intersection of the plane LMN and plane QLS. Okay, so here we have, let's look at our plane. So a plane, let's look at plane LMN. Where's LMN? LMN is this plane right here. Maybe I should use a different color. Use red. So yeah, can you see this? So plane LMN is the red one I'm just marked, and then plane QLS, let's use, I don't know, green. QLS is QLS, this plane right here. It should be green. Why is it red? So this plane right here. And then the other plane is this one right here. Okay, so what would be the intersection? Name the intersection or name the ray that intersects these planes. It would be ray LQ, right? LQ intersects the green plane and the red plane. Okay, so it's going to be ray, yeah, ray LQ. Okay, let's look at number 12. So we have line segment PR. So we have this line segment PQRST, and they're saying that line segment PR is congruent to RT, and line segment RS is congruent to ST, and then line segment QR is equals to 4, and line segment ST is 5. So let's kind of draw our figure. Okay, so kind of gave you the first one. Uh, let's see, PR, line segment PR is congruent to RT. So here's PR is congruent to RT. So this is congruent with that. And RS is congruent to ST. So RS is congruent to ST. And QR is equal to 4. So this distance is 4. And then ST is 5. Okay. If you want to draw PRT, so maybe we can also draw another line segment. So let's stick with PRT. PRT. So let me draw this again, make it more clear. So here's P, R, and T, right? So this is Q, and then this could be like S. So PR is congruent to R, PR. So wait, you could say that this congruent, line segment PR is congruent to RT. So what should be, and then they're saying that RS. So what do we know? So they want to know the length of RS. Well, we know that RS is going to ST, right? So let me draw another image. Okay, so yeah. So what do we know? We know that RS is equal to 5. Wait, yes, RS is can equal to 5 because ST is also 5, right? ST and RS are congruent. They should equal to the same distance, 5. And QR is 4. And then we don't know the distance of PQ, so we'll call it X. So yeah, so the first one is line segment RS is 5 because line segment ST is 5. What about the length of RT? So here's R and here's T. So it's just the mixture of line segment RS plus line segment ST, right? And that is going to be 5 plus 5, so that is 10. So the line segment of RT is 10. What about the line segment of PR? So PR, well, I don't know what it says line segment PR is congruent to RT. So we know that RT is 10, so that line segment PR should also be 10. Okay, whoops. Here's PR right here. PR should be 10. Okay, what about the distance of PQ? Well, what do we know? We know that we don't know what the distance to PQ is. We'll call it X, but we know the distance from QR is 4. And what else do we know? PQ. So yeah, we don't know the distance of PQ, so we'll call it X plus the distance of QR, which is 4. And then that should equal to the distance of RS, right? I mean RT, because RT, because they said that the distance from PR, so this distance is equal to this distance. So X plus 4 equals to 10, right? Okay, solve for X, you're going to subtract 4 from both sides, and you get 6. So the distance of PQ is 6. Okay, let's move on to the next one. So use the figure. We want to know the distance of MP, SM, NR, and MR. So here's our figure. They're saying that line seg. Uh, um, The total distance is from SR, and we want to know the distance from MP. So MP is, oh, they also should have told you this. On the problem, it also says that MN, this is given. MN equals 8, and line segment SR is 26. And they also said that line segment SM is congruent to line segment MP, which is also equal to line segment PN. Okay, so part A, what is the distance from MP? So the distance from MN is 8. And to get, so this distance from here to here is 8. And then we also know that MN is a mixture of MP and PN. And it should equal to 8. And they also said that the line segment M at MP is equal to the line segment PN because you have these congruent signs. But I don't know what their length is. We'll call it X. Maybe I'll call this X. So X plus X equals 8. Solve for X, so this would be 2X equals 8. Divide this by 2, X equals 4. So MP is 4. Okay, part B says find the distance from SM. So SM is congruent to MP, right? SM is congruent to MP, which is congruent to PN. Do you see these three marks? That means congruence. So SM is going to be 4. What's the distance from NR? So NR, I'm not sure. Well, we know that this distance, SM, MP, PN, but we don't know what NR. And what else do we know? That the total distance of SR is 8. So NR. So we know that the distance of line segment SM plus line segment MP plus line segment PN plus line segment NR is going to equal to the total distance of NR. Yeah, we don't know what it is going to be equal to the total distance of SR. So we know that line segment SM is 4. The same thing with MP is 4. The same distance of PN is also 4 because they all have these congruence marks. I don't know what the line segment of NR, so I'm going to call it X. But I do know the line segment of SR, which is 26. That was given right here. So now we could find it. 4 plus 4 plus 4 is 12. Solve for X. 26 minus 12 is 14. So the distance of NR is 14. Okay, D, find the distance of MR. So where's MR? So MR is going to be a mixture of MP, PN, and NR is 14. Where's MR? Oh, so also NR, sorry. Okay, so the distance between MR is a mixture of MP, PN, and NR. That gives you the total distance of MR. Okay, so we know that the distance of MP is 4. We know the distance of PN is 4 as well. Do we know the distance of NR? No, we don't. So I'll call it X. And then do we know the distance of MR? Uh, no, we don't. Wait, actually, we do know the distance of NR, which is 14. So the total distance of MN is 4 plus 4 plus 14 is 22. Okay, let's move on to number 14 through 7. Use a triangle. For 14 through 17, use a triangle. Name two complementary angles. So here we have an angle. Here you have two different triangles and one triangle. We need two complementary angles. Complementary means 90. Exactly 90, right? So it also has to be adjacent. The adjacent, so adjacent angle sums up to 90. So let's see, what could it be? So what about ABD and angle DBC? So if you add 42 and 48, does that give you exactly 90? Yes, it does. So two complementary angles would be angle, and they have to be adjacent. It would be angle ABD plus angle DBC. Okay, that was 14. 15 says name a right angle, so exactly 90. So a right angle would be just angle ABC. So ABC is this making up these two angles. So angle ABC. 16, name an obtuse angle. So an obtuse means greater than 90 but less than 180. So that would be angle I'm going to say angle ADB because what is this angle length? Well, I don't know what it is, but I do know that this forms a straight line, and straight lines always add up to 180. So this angle is called X. This angle here is 84. They form a straight line, so they equal to 180. Track 84. You get X equals 180 minus 84, which is 96, which is greater than 90, right? But still less than 180. So that's what makes it obtuse. So it would be angle AVB. Okay, number 17. Name a linear pair of angles. So what are linear pairs? Basically two angles on the same line and their sum adds up to 180. So two angles on the same line and their sum is 180 degrees. So what would that be? 17. I would say angle ADB plus angle BDC, right? So these two angles form 180 degrees. So angle ADB plus angle BDC. So basically these two angles, this angle here and this angle there. Angle ADB plus angle BDC. Okay. For 18 through 21, use a diagram to decide whether the statement is always, sometimes, or never true. So we have so for 18, anyone use a diagram to decide whether the statement is always, sometimes, or never true. So we have angle 1, 2, 3, 4, and then this 90 degree. So when 18 says, if angle 2 is 115, then angle 3 should equal to 65. Is that true, sometimes, or never? So if angle 2 is a 115 and angle 3 is 65, uh, is that always going to be true? So angle 2 and angle 3 are linear pairs, meaning they form a straight line or equals to 180. So so if you look at the, I draw an image, here's 115, and then here's 65. So is this true? It has to be always true, right? Because this is a straight line, this is a linear pair. They always have to add up to 180. So 115 plus 65, that equals 180. So I'm going to say always. What about number 19? Does angle 3 is congruent to angle 4? Is angle 3 is congruent to angle 4? Here's angle 3, here's angle 4. Uh, Sometimes, right? We don't know what angle 3 or what angle 4 is, but they can be congruent, right? This angle 4 and angle 3 forms a right triangle, so it's like a 90 degree, right? So there could be a situation where both angles are 45 and 45, right? That gives you 90. But there could also be a time when their angles are too different, but they still add up to 90, right? Maybe like 60 plus 30. So I'm going to say, yeah. So it can't be never, it can't be always. So I'm going to say sometimes. Number 20, if angle 1 is 40 degrees, then what should angle 3 be? I mean, if angle 1 is 40 degrees, then angle 3 should equal to 50 degrees. If angle 1, so 21 says, if angle 1 is 40 degrees, then what should angle 3 be? Angle 1 is 40 degrees, and then angle 3 should be 50 degrees. That's never going to be true. Why? Because what's the relationship between angle 1 and 3? They are congruent because they are vertical angles, right? All vertical angles are congruent. So this is never going to be true. They have to always be congruent. So never. Okay, 21. Angle 1 and angle 4 are complements. So complements are, so angle 1 and angle 4 are complements. Uh, I'm gonna say always. Angle 1 and angle 4 are complements because angle 1 is congruent to angle 3, and angle 3 plus angle 4 is going to be 90. So on 21, I'm going to say yes. Angle 1 is going to equal to angle 3, and angle 3 plus angle 4 is equal to 90 degrees. So I'm going to say always. Okay, so let's move on to number 22 through 27. Find the measure of, so here we have this image, and we got to find the angle. On 22 says find the angle DB. So let's look at our image. Let's locate where angle DB is. Here's, uh, this should be a D. Why did I put an F here? This should be a D. So DBE is this angle right here. Uh, well, I know that, we know that angle F, this should be B here. Angle FBD is 90. So let's see. Question says, what is the angle of DBE? Well, I know that angle, it's going to be 45. It's going to be angle FBE plus angle EBD, right? Which we don't know, call it X. And it equals to the angle FBD, which is 90. Subtract 45. So 90 minus 45 is 45. So angle DBE is 45 degrees. 23, what is the angle FBC? FBC is this entire angle. So FBC is a mixture of angle FBE plus angle EBD plus angle EBC, right? So FBC is a mixture of FBE, FBE plus angle EBD plus angle DBC. Okay, so do we know what angle FBE is? Yes, 45. Do we know what angle EBD is? It's the same thing as angle DBE, right? EBD is the same thing as angle DBE, so that's also 45. Plus angle DBC, which is 50. So this is going to equal to angle FBC. Okay, so you just add them up and you get 140 degrees. 24, what is the angle of ABF? ABF, so what do we know? We know that this uh, ABC forms a straight line. So this angle plus this angle plus this angle plus this angle is going to form a straight line 180 degrees, right? Okay, so we can just set it up as so DBC is 50, DBE is 45, angle EBF is 45, and then I don't know what angle ABF is, so I'm going to call it X. And they all add up to 180 degrees. So 50 plus 45 plus 45 is 140 plus X equals 180. Subtract 140, which is 40 degrees. Okay, last one, angle DBA. DBA. So DBA is a mixture of DBE, EBF, and FBA, right? So it's going to be DBA. So it's a mixture of angle DBE, which is 45, plus angle EBF, which is also 45. And then we don't know what angle FBA is. We'll call it X. And DBA. Wait, I think we do know what DBA is. Okay, no, we don't. But we do know that if you add up angle DBA, I mean DBC, that's 50. And they all form a straight line, right? So you're going to set it up to 180. So 45 plus 45 plus 50 is 140 plus X equals 180. Subtract 140, you get X equals 180 minus 140, which is 40 degrees. So angle DBA is 40 degrees. No. DBA, I'm confused. FBA, I was looking for angle FBA. So let me do this probably again. DBA is a mixture. Wait, we needed that. We needed to do that one because now we have 40 degrees, which is angle ABF, right? We needed that. So we want to find out angle DBA. So this entire angle right here. So we know that this is going to be 45, this is 45, and then this is 40. That gives you that angle. So angle DBA is going to be 45 plus 45 plus 40, which gives you 130 degrees. Okay, 26. Name the bisector of angle FBD. FB is right here. FBD. So the bisector of angle FBD would be angle EBD. I mean, BE, right? Ray BE. Okay, 27. Name three adjacent angles to angle DBC. I forget to put a B here, DBC. So name three adjacent angles to angle DBC. So one would be angle EBD. Another angle would be angle FBD, and another angle would be ABD. So here's angle DBC. Three adjacent angles would be EBD, FB, FBD, and angle ABD. Okay, let's move on to 28. So line segment PQ has endpoints of point P negative 3, 8 and point Q 3, 6. Find the midpoint of line segment PQ and the length of PQ. So you just have to know your formula. So what is the midpoint formula? Basically, you take the average of the x and y's, right? So x1 plus x2 over 2, comma y1 plus y2 over 2. So my 2 points are negative 3, 8 and 3, 6. So I'll call this x1, y1, x2, y2. x1 is negative 3, x2 is 3, y1 is 8, y2 is 6 over 2. Negative 3 plus 3 is 0. 8 plus 6 is 14 divided by 2, which is 7. So here's our midpoint. And then what would be our distance? Find the midpoint, find the length of PQ. So the distance is going to be x2, which is 3, minus x1. y2 is 6, minus y1. Two negatives becomes a positive, so this is 6 squared. 6 minus 8 is negative 2 squared. So that is going to be 36 plus 4, which is square root of 40. And then you can simplify square root of 40 if you like. Two numbers multiply 40 would be 10 and 4. None of these are prime. 4 could be broken down as 2 and 2. 10 could be broken down as 5 and 2. So you have a pair of 2s. So that takes out, you put it outside, so it's 2. And then inside your leftovers are 5 and 2, which is 10. Okay, so your distance could be expressed as radical 40 or simplified as 2 radical 10. Twenty-nine says C is between A and B. Find C is between A and B. Line segment AC is 2x minus 3. Line segment CB is 4 plus x. And line segment AB is 34. Find the values of x and find the lengths of AC in line segment CB. So let's draw our image. So C is between A and B. So A, here's C, and here's B. So the distance from AC is 2x. This distance here is 2x minus 3. And find the distance of CB, which is 4 plus x. And they're saying that the total distance from A to B is 34. So let's make an equation. So let's first solve for x. So what I know is that the line segment AC plus line segment CB is equal to line segment AB, right? And we know that the line segment AC is 2x minus 3 plus the line segment of CB is 4 plus x. And that gives you a total length of 34. Okay, now we can solve for x. So 2x plus 1x is 3x. 4 minus 3 is 1, equals to 34. Solve for x, so you're going to subtract 1. 34 minus 1 is 33. Divide this by 3, and you get 33 divided by 3 is 11. So find the length of AC. Now we can because we have the x, right? So it's 2 times 11 minus 3, which is 22 minus 3, which is 19. And then the distance of CB is 4 plus x, or 4 plus 11, which is 15. Okay, so the distance from AC is 19. The distance of CB is 15. Is that what they're asking? Yes, find the lengths of AC and find CB. Okay. On that one, so number 30. So 30 says find the values of the variables, and we have this mess. Well, what do we know about this mess? We know that these two angles are congruent because they're vertical. And maybe we can set up an equation already. So we can say 6x plus 4x plus 16. And what else do we know? We also know that this angle here is congruent with this because they're also vertical angles. So this is going to be 11y. Well, we can't just solve our variables for this one because they're two different letters, right? Or can we? Yeah, no, we can. We can solve for x. Okay, so I'm going to solve for x. So by subtracting 4x, 6x minus 4x is 2x equals to 16. Divide this by 2. X equals 8. We're probably going to need this. So x equals 8. Now, how do we find our y? What else do we know about this image? So we know that this angle plus this angle forms a straight line or a linear pair, meaning they add up to 180, right? You could say 11y plus 4x plus 16 equals to 180. And what else do we know? We know that x is 8. So we could say 11y plus 4 times 8 plus 16 equals 180. So 4 times 8 is 32 plus 16 equals 180. 32 plus 16 is 48. 80. Subtract 48 from both sides. We get 11y equals to 180 minus 48, just 132. Divide this by 11. Just 12. So y is 12 and x is 8. Okay. Let's move on to 31. Okay, so 31 says find the values of the variables. We have this image. We have 2x, y plus 10, x, and 2x, or wait, and this y. So we got to find x and y, right? And they don't give us, let's just use what we know. So I see vertical angles. I see this angle is congruent with this one because it's a vertical angle, so that's going to be 2x. And what else? What else do I know? This forms a right angle, right? And what else? If you add up this entire 1, 2, 3, 4 angles, they form a straight line, so that equals 180. So let's set up our equation. So we said that these two angles, y plus 10 plus x equals 90. And then if you add up these four angles, it would be y plus 10 plus x plus 2x plus y equals 180. Okay, so what do we know? We can't like solve here because they're two different letters. Yeah, we kind of have a problem. So maybe we have to create a system of equations. So can we simplify this side? Yes, we'll say y plus 2x, and then our constants are 10. Wait, so you have, so let's collect our letters. So we have 2x here, 1x there, that's 3x. Y plus y is 2y, and our constant is 10, equals 180. Subtract 10 from both sides, and you get 3x plus 2y equals to 180 minus 10, which is 170. Same thing here. Let's get all the x's on. So we have an x and a y plus 10 equals 90. Let's move this constant to the right by subtracting 10. So we get x plus y equals 90 minus 10 is 80. Okay, and then let's set up a system equation. So we're going to say 3x plus 2y equals to 170, and then x plus y equals 80. And then here's equation 1, here's equation 2. Let's get rid of the, I don't know, x. I think I made a mistake somewhere. Did I make a mistake? So we have y plus 10 plus x plus 2x plus y equals 180, and then 2x plus 1x is 3x. 1 plus 1, 1y plus 1y is 2y, plus 10 equals 180. Good. 3x plus 2y equals to 170. Solve for x, so you're going to subtract 2 from both sides. So I'm going to try to get rid of the y by multiplying the entire equation by negative 2. So you have 3x plus 2y equals to 170. And then if I follow out this is negative 2x minus 2y equals to 80 times negative 2 is negative 160. So the y's cancels, 3x minus 2x is x, and then 170 minus 160 is 10. Good. So I'm doing it right. So x does equal to 10. Now let's solve for y. You could plug in your x into this one equation. So it's 3x plus 2 times, it's 3 times x plus 2 times y equals 170. 3 times 10, 3 times 10 is 30, plus 2y equals 170. Subtract 30 from both sides. 170 minus 30 is 140. Divide this by 2, you get 70. So y equals 70. Okay. So yeah, that's how you do that problem. Move on to 32. So the number of dots in these triangular arrays are called triangular numbers. So we have 1, 2, 3. We have four triangles, right? This has 1. This has 3 dots. This has 6 dots, and this one has 10 dots. So the question says, what is the next triangular array? So basically, how much dots do we need? So from image 1 to image 2, you had to add 2. From image 2 to image 3, you had to add 3. And then from image 3 to image 4, you had to add 4. So you're adding 1 each time. So the next one, you have to add 5, I believe. So here you have 10 dots, so you have to add additional 5 to get the next image. So that would be 15 dots. And if you draw it, you can draw it like this. 2, 3, 4, 5. And you have 1, 2, 3, 4, 5. 2, 3, 4, 5. And then 1, 2, 3, 4, 5. 2, 3, 4, 5. 3. Well, whatever. You just have to have 15 dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I have too much. Okay, so you should have 15 dots here. And yeah. Okay. The next one says for 33 to 35, determine the perimeter and area for each figure. So on this image right here, we have 2 triangles, or actually 3 two smaller ones, and then 1 main one. This distance is 21. This is 8. This is 10 and 17. So we can easily find the perimeter already. To find the perimeter, you simply add all 3 sides. So you have 10, 21, 17, 10, 21, and 17. That is 48. And then find the area the area of a triangle is base times height over 2. So my base is 21. My height is 8 all over 2. So that's 168 over 2, which is 84. Okay, so the area is going to be 84 units squared. And then my perimeter is 48. And it can be units. Okay, let's move on to 34. So we have a circle with a radius of 3. Now, to find the perimeter of a circle, it's really the circumference. So the circumference of a circle is 2 times pi times r. And the area of a circle is pi r squared. Okay, so let's find the circumference is 2 times pi. My radius is 3, so that would be 6 pi, right? And then the area is pi r squared. My radius is 3 squared. So that would be 3 squared is 9, times it by pi, so that's 9 pi. So my area is 9 pi units square, and then my circumference is 6 pi units. Okay, let's move on to 35. So we got to find the perimeter and somehow the area. And this is all they give us, right? So we kind of have to find like, oh, this should be 11 right here. Yeah, so we have to find this distance and this distance. We'll call this distance right here x, and then this distance here y. So how do we do that? How do we find this distance? Well, you can break it into 2 different shapes. Or So maybe if I put like a straight line here, we have two images. Here's the first image, and then here's the second image, right? Can we find y? Kind of, yes, we can. So this total distance is 8. And then this distance here is 5. So you can set it up as 5 plus, I don't know what this distance is, so I'll call it y. And then the total distance is 8. Solve for y by subtracting 5 from both sides, and you get 3. Okay, so this is going to be 3. And then what about the distance of x? Well, I'm not sure. Well, I do know that this distance here is 6 because this is a rectangle. I don't know what the distance of x is, but I do know the entire length is 11. So you can set it up as x plus 6 equals 11. Solve for x, so you're going to subtract 6 from both sides, and you get 11 minus 6, which is 5. Okay, so x is 5, and now we can find the perimeter. So the perimeter is, so x is 5, and then this is 3. The perimeter is 5 plus 11 plus 8 plus 5 plus 3 plus 6. And that gives you 38. And then the area is, let's just take the area. So we have, let's do the first rectangle and the second. So the first rectangle of the area is base times length times width, or base times height, which is 6 by 3, which is 18. And then the area of the second image is going to be, the base is 11, so this one right here is 11, and then the height is 5. So 11 times 5 is 55. So you have to add up those two areas, which is 18 plus 55. So the area is 73 units squared. Okay. So the total area is 73 units square, and then the total perimeter is 38 units. Okay, good. We just finished this chapter test, so we can stop here.